Hey everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this challenging integral to solve. But if you're watching this video, that won't be difficult for you anymore. Okay, we have integral of dx over square root of 10x. Okay, so the first approach that we're going to apply here is the substitution method. Substitution method, we will let the tan of x to be equal to a new variable. So we can now let that tan of x is equal to t. But since there is square root, it's better to let by being t squared. Why t squared? Because these two will simplify with the index. Okay, so now doing that, if we differentiate the left side and differentiate the right side, here we're going to have 6 squared, and we don't have 6 squared in our integral. So what we do then, we can isolate x, so that when we differentiate x, we know that the derivative of x is 1, so we will simply have dx. Okay, so if we isolate x, then x will be inverse tan of t squared. If that's the value of x, then what we can do now is differentiating both sides, left side and right side. The derivative of x will be 1, so that means it's dx, to show that we're differentiating with respect to x. And the derivative of the inverse tan is the derivative of the argument, which is t squared. In this case will be 2t over 1 plus the argument squared. But my argument is t squared. So if I square it, will be then t to the power 4. Okay, so this is now the value of d of x. Now substituting in our integral, then we're going to have the value of dx is this expression. So 2t over 1 plus t to the power 4 over the square root of this expression is t, because tan is t squared, so that means it simplifies with the index and becomes just t dt. Now if we go further, what do we realize? We apply the principle of dividing into fraction, which is multiplying the first one by the inverse of the second one. So if we apply this fraction rule here, we're going to have 2t 1 plus t to the power 4 times 1 over t dt. Okay, so we can simplify this t and this t. We're simply going to get 2, in this case just 2t to the power 4 plus 1 dt. Okay, so that's the expression that we get. So to solve this integral now, we can apply decomposition in my denominator, or we can apply another mathematics trick, which is the one that we're going to be using. Instead of applying the composition method, which you are more than welcome to apply, but we're going to factorize the half of this expression. If it's t to the power 4, then that means the half of 4 is 2. Then we're going to factorize t squared in this particular case. So if we factorize t squared, what are we going to get? We're going to get integral of 2 t squared plus 1 over t squared dt. Because when we multiply, this becomes t to the power 4, and this simplifies, goes back to 1. So this t squared is in denominator, so can come here as the denominator of 2, nothing will alter. So that means what is going to happen? We're going to have in this case now integral of 2 t squared over t squared plus 1 over t squared dt. Okay, so perfect now. So what do we do now? If we see we have t squared plus 1 over t squared, we can simply apply this approach, a squared plus b squared. We know it's equal to a plus b squared minus 2ab. So if we apply this identity here, that means we're going to have t squared plus 1 over t squared is the same as t plus 1 over t, in this case our b, squared minus 2 times a times b 1 over t. So they simplify, simply becomes minus 2. So that's the problem. But if we look, this expression here was transformed with plus here, and the 2 here is negative. What if I decided to use negative? So this expression can also be the same as t minus 1 over t squared, but when here is negative, I will use 2 as a positive. Okay, so you could be wondering, why then this approach? Why couldn't we just skip this expression we had to also use? We will apply here in a few minutes now, in a few seconds. Okay, Now, this expression where there is 2 over t squared, we can reduce this expression into 1 to the power t squared plus 1 over t squared. Because they have the same denominator, we can add the numerators, we'll go back to 1. Okay, so if I say, let's just write like that. If I say 1 plus 1 over t squared plus 1 over t squared minus 1. This is still the same. This one I can cancel with the 1. And if I simplify, if I operate here, I keep the denominator, I add the numerator, I go back to 2. Okay, now, what happened in my denominator? In my denominator, I have, which is this expression, t squared plus 1 over t squared dt. Now, the thing is, I can separate this expression with the denominator and this expression with the denominator. So, if I do so, then what I'm going to get is like I'm going to get 1 plus 1 over t squared over t squared plus 1 over t squared dt. If I factorize negative 1 there, then I'm going to have minus integral of 1 minus 1 over t squared over t squared plus 1 over t squared dt. Okay, perfect now. So what do we do now? We have this denominator and this denominator. Now we're going to apply the approach that we were just proving there. If we check the derivative of this expression, if we derivate this expression, if we derivate the derivative of t plus 1 over t, we're going to get the derivative of t is 1, the derivative of 1 over t is minus 1 over t squared. Okay, so we realize that the derivative of this expression gave this expression. This expression is here. So what if we derivate t minus 1 over t then? Then we realize that the derivative of t is 1, or of 1 minus t is negative 1 over t squared. So this negative and this negative become plus. So we realize that derivating this part, we get this part which is on top here. So we know which transformation we can use for each denominator. Okay, so that means for this one, the derivative that gave us this one was this one. So that means for this one, we're going to use t minus 1 over t. So we can use, now in this case, t minus 1 over t squared. It's negative, so that means plus 2. And for this one, we're going to use the positive one. So which is t plus 1 over t squared minus 2. Okay, now perfect. That's the approach that we're going to be using. Now, we know that the derivative of this expression generates this expression. Okay, so we can say now the derivative of t minus 1 over t over t minus 1 over t squared plus, I can say square root of 2 squared minus integral, the derivative of this expression, which is this expression, t plus 1 over t over t plus 1 over t squared minus square root of 2 all squared. Okay, perfect, because if I this derivative, if I derivate this expression, I get this expression. If I derivate this expression, I get this expression. This integral reminds us integral of dx over x squared plus a squared. The argument is the same as the base, which is not different. Our argument is the same as the base. And this reminds us 1 over a inverse tank of x, which is the argument, over a. So we can apply this approach here. So that means for that particular case, our integral will be in this case 1 over a. What is our a? Our a is the constant squared, so square root of 2. 1 over square root of 2 inverse tank of x over a. But our x is t minus 1 over t, which is t minus 1 over t. Okay. Over a, which is square root of 2. So t minus 1 over t over square root of 2. Okay, perfect now. Now what about this one? The argument is the same as our argument here. So this reminds us the integral dx over x squared minus a squared, which is 1 over 2a ln of x minus a over x plus a. Okay, so we can apply this one here also. So we're going to have that will be minus 1 over 2a. What is our a? Our a is square root of 2. So 2 times square root of 2. Okay, ln of x. In our case, x is t plus 1 over t. So t plus 1 over t over, of course, minus a minus square root of 2 over t plus 1 over t plus a plus square root of 2. But our problem was not given in t. It was given in which respects to tan. So we can isolate t by saying that t is square root of tan. Okay, so if t is square root of tan, then in this particular case, our solution will be 1 over square root of 2, 1 over square root of 2, inverse tan of x minus 1 over square root of tan of x over square root of 2 minus 1 over 2 square root of 2 ln of square root of tan of x plus 1 over square root of tan of x minus square root of 2 over square root of tan of x plus 1 over square root of tan of x plus square root of 2. This plus c. So this is how we should solve this problem. So this is the solution of that particular case. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.